My name is Todd Patizanen. I'm a U.S. sales manager for FLIR, and I'm not the sales manager. I'm one of the U.S. sales managers. My team focuses on manufacturing key accounts. So we cover people mostly in chemical processing, pulp and paper, steel manufacturing, and automotive. Some of you are from BP Whiting here today, right? Yeah, thanks for coming. You're actually not covered by someone on my team. But I brought some of my cards here. You can grab those in the back. And we have a local technical sales representative, Vito DiFrancesco, in the back as well. Make sure you get his card. He's your local point of contact from us. Who in the room is familiar with thermographic imaging for electrical or mechanical maintenance? Okay. That's, I'd say, at least half of you. Has anyone gone to infrared training to get certified, level 1, level 2? Yeah, okay. Well, for those of you who have been to our certification training, you know that's a 4-day, 32-hour process. And it's not what I'm going to do today. This is not going to be a technical presentation today. You're welcome. Especially not after lunch and people are thinking about beating rush hour traffic to get home. I want to talk about how this solution fits into what my colleagues have been talking about all morning and afternoon, which is reliability-centered maintenance and with a particular focus on safety. I'm going to get a little more into topics of productivity and a tiny bit on quality control as well. And I want to leave plenty of time before we all say goodbye, that Vito and I can help you. Maybe you may have noticed at the beginning, we have a table full of cameras in the back to give you some idea, especially if you've never used a tool like this before, to give you an idea of the ease of use. All right. So the last thing I'll say, this technology has come a long way, and especially the user interface in most of the portable thermal imaging tools that you'll find on the market. We're one of them. We're not the only one. I believe that we offer a lot of value, but this isn't a sales presentation today. The point I'm trying to get to is you don't need to be a technical expert to learn how to use one of these tools accurately anymore. Now, the more complicated the application, the more technical training you ought to have. And I do encourage your organizations to have at least a few certified thermographers on staff. But we also have, not we, the market has tools available now where you can have a fairly inexpensive thermal imager in every technician's tool bag and take advantage of some of the other solutions that we learned about earlier today, like these engineered solutions like infrared windows or ultrasound ports in cabinet doors and so forth. I have two identical looking glasses of water here, right? If you were just looking at these from a distance, you'd have no idea which one was hot, which one was cold. The advantage of thermal imaging is that it can bring to light these sort of parameters that you don't see with the naked eye. And if you can imagine that this was electrified equipment, you can't touch it. You can't do a contact temperature measurement on that safely. You could. That might be the last thing you do. And so it's a really unique application that's become more and more common. This is the only technical part of the presentation I'm going to do today. If you're familiar with electromagnetic spectrum, this is radiation that goes all the way from at the low end with the very short wavelengths, gamma rays, X-rays, ultraviolet, into the visible spectrum. And then just beyond the visible spectrum is where these tools operate. They operate in that infrared spectrum. Above that, you have microwaves and you have radio. And I remember being fairly old whenever I finally learned and realized, oh, this is all the same thing. The X-rays that you get at the dentist, the radio that you're listening to in the car, and the light that we see, it's all the same thing. We actually started as a defense supplier, and the earliest applications of infrared imaging were really for that kind of application, that if you're in the military and you're in the woods and you're trying to identify the enemy, this was a way to sort of see through cover. People think about this as night vision, and you can use it as night vision, but it's not just night vision. This works in broad daylight as well. Okay, a lot of the topics today have been about safety and having zero injuries in the workplace, about maintaining reliability and system uptime. And as I mentioned, I'm going to get into briefly discuss quality and also productivity specifically with thermal imaging solutions. But all of this is going to contribute to your company, to your employers' profit and growth. We have to think about safety and reliability first, but the people that are paying most of our paychecks, probably all of our paychecks, they're concerned overall about, not just literally, but also financially keeping the lights on. There's been some discussion, especially this morning when Rudy and Iris were talking about this. This increased awareness across multiple industries about electrical safety, it's having an effect because the injury rate and the fatality rate has been steadily declining for decades now. It's not down to zero yet, but that's the good news, is we are all moving in the right direction already. This has been a topic from all the presenters today as well, the total cost of downtime. It's more than just the cost of repairing or replacing that component, that asset, that malfunction that contributed to loss of production or loss of lighting or whatnot. It does include things like parts, labor, contractors, equipment rentals, and of course the lost revenue. That company is leaving dollars on the table as long as they're not producing product and it's not going to get to market tomorrow. They're going to have to wait a week. They've just delayed a week's worth of revenue because of that. But there are the indirect costs of downtime as well. If this has a negative impact on the market, it can erode customer confidence. It can draw people like us into a conference room for half a day or for a couple of days to go through corrective action planning. It may require some employee retraining if you find out that this was a procedural error that needs to be corrected. It can reduce employee morale and on and on. There are indirect impacts on the cost of downtime as well, especially if it is a recurring problem. Cost of poor quality. We saw an iceberg metaphor earlier today. This is another one. If you're on the production side of your employers, then you may be familiar with these ideas of testing and identifying bad material and either scrapping it or doing rework. These are obvious direct costs. Some of the other costs that are not necessarily considered are everything that you see, below the water. That part of the iceberg below the water that you don't realize in a timely enough manner. And it can be, again, a lot of similar things to the indirect costs of unplanned downtime as well. Lost market share, loss of employee morale, additional management meetings, customer complaints. It's a very similar and related topic as well. So we're talking about safety and how safety and reliability are intimately interrelated. So then is reliability and product and quality as well. And last is the cost of productivity. Our Steelers fan here in the middle of the room told us this morning how your data collection is still paper and pencil, right? And then someone's got to go back to the office and key all that in. There's room for human error in that. Other presenters today have talked about the increased importance of data capture. So I'm going to talk about solutions that will allow you to not only make accurate temperature and electrical measurements on your various assets, but also more, let's say, foolproof ways to take that data that you've captured, bring it back to the office, and put it into something as simple as a paper report, all the way the other end of the spectrum of bridging that to an enterprise resource platform that your employer may be running, SAP, Oracle, ABB, etc. Okay, but first we talk about electrical safety, and I won't spend much time on this because Rudy really hit this home this morning. Just a brief reminder, particularly about what happens in an arc flash incident. Luckily, I've never been in one or even witnessed one. Has anybody experienced it or been close to one? It seems frightening. Before I came to FLIR, I worked for ABB High Voltage Service, and I had a colleague there who, when he was younger, was an electric service technician And he has permanent hearing loss and scarring that you can see on his arms from arc flash incident that he experienced himself, you know? So I'm thankful I've never had to deal with it. I'm sorry for those of you who had, and of course I think about my colleague a lot whenever we talk about this. It's more than just an electrical event. This is going to create tremendous amount of heat. It's going to send out a shock wave. It's going to send hot shrapnel flying. And if you're wearing a PPE, that's great. It ought to keep you alive, but it doesn't necessarily prevent other injuries, some of which would require hospitalization or care, and some of which might be permanent, like my former colleague's hearing loss. A couple other statistics about electrical hazards then. There's a distinction at the Bureau of Labor and Statistics between direct and indirect exposure. Direct exposure is just what it sounds like. If you are working on or touching energized electrical equipment and electrical injury results, that's direct. And indeed, over 90% of those injuries reported came from a direct result of either building, repairing, maintaining, or operating that electrified equipment. Very little incidental direct exposure resulting. But what was surprising to me when I was researching this a bit is the effect of so-called indirect electrical exposure. So this would be, for example, if somebody's carrying a ladder through a plant and they inadvertently contact energized bus or an overhead line. Or if somebody's doing work standing in water without realizing that there's current running through that water. Those kind of injuries can have a devastating effect as well, perhaps partially because those people aren't necessarily dressed and equipped for electrical hazards. And the table that I took from Bureau of Labor Statistics about this one talks about 30%. So, you know, almost 1 in 3 of those kind of indirect injuries, they'll send people off work for over 1 month, which is, I think, a serious injury if you've got to take at least 30 days off of work. So again, the topic throughout today is about reliability, but it goes hand in hand with avoiding those hazards. Okay. Rudy broke down the hierarchy of controls that's in NFPA 70E, and I think I saw a lot of heads nodding in the room today. Lots of awareness about this already. So once again, as the substitution and engineering controls that you can get with elements like infrared windows, you know, our tools obviously go hand in hand with that. You've got the window to make the environment safer, to reduce your risk, and then you've got ultrasound, infrared, other measurement devices that will operate safely through those devices. So, you know, depending on the camera, we have some that are small and they fit in your pocket. We have one now that plugs into an iPhone or an Android phone. But we've got more sophisticated ones as well that you can put on a telephoto lens and measurements from 25 or 50 feet away. The point is staying well outside of that approach boundary. So again, Rudy pointed out this morning that just the act of opening that door presents a greater hazard, and the individual doing that activity needs to be prepared appropriately. That said, if there's an opportunity to inspect electrical equipment, whether it's in an open door or whether it's, you know, overhead conductors in a high voltage transmission system, it can be done very safely with a portable measurement tool like this. So I've said it a couple of times already. These are non-contact measurements. You can stand at a distance and infer things about your electrical system just by measuring that temperature. These sort of instruments will give you quantitative data. Now, again, it does require some training. It doesn't have to be that 4-day certification course, but it does require some training and understanding of the technology and the tools and its limitations and how to be accurate. And you guys who went to the certification training, do you remember the acronym FORD? It's focus. Why am I? Yeah, focus. It's not range. Yeah, temperature range and distance to the target, right? Focus meaning just like a visible image. If you want accuracy in the temperature measurements, then the object you're trying to target needs to be in focus in that image. The temperature range is basically the minimum and maximum that this tool is capable of measuring. If you have a camera in your hand that has a maximum temperature range of 650 degrees Fahrenheit, and you're actually trying to measure something that's at 850 degrees Fahrenheit, you're not going to be accurate. The camera won't be able to give you accurate results. And the distance. Distance has to do with the resolution of the camera. We can only resolve an individual pixel in that image. So if what you're trying to measure accurately is smaller than a 3x3 box of pixels, your accuracy is going to be questionable then as well. Those three things cannot be changed once an image is captured. But everything else can be. Somebody mentioned this morning emissivity. This is a property of all materials that talks about how efficiently they emit the heat that they're storing. So emissivity is probably the most important variable in accurate temperature measurement whenever you're doing thermographic imaging. But you can modify that later whenever you're sitting down and you've got the camera in front of you, or you can offload the data that you've captured in that camera, put it into a software tool on your desktop, and you can do all of the adjustments there. But the most important things whenever you're taking these measurements, the things that cannot be changed are the focus, the temperature range, and your distance to the target so that you can resolve and measure accurately. I think it's an obvious answer, but knowing all that we've learned today, which of these methods is going to be more efficient and less risky? Will it be the beekeeper suit? No, yeah, that's right. It's going to be the one on the right. There was some discussion also about increased inspection frequency, increasing that mean time between failure for critical assets. I'm gonna come back to that one a little bit later on a different slide. Come back to that topic with a case study about another pulp and paper company. Maybe not the same one that got discussed earlier, but this one also will remain anonymous. So for very critical assets, you can also set up thermal imagers to do continuous condition monitoring. And it can be a very simple solution, like this camera that I've got up here. It's about the size of a deck of cards, and it can be directly connected to an individual computer. All you need is a web browser, and you can configure and capture data from this camera right out of the box. So the industry really has gotten to a point that we now have almost DIY solutions for continuous condition monitoring. There are also automation integrators all over the country and really all around the world who specialize in more complicated solutions where something out of the box isn't going to exactly satisfy your needs, or the admitted measurement limitations of a smaller, less expensive device like these that may not meet your needs. And they can do the complete systems integration, including explosion-resistant enclosures and complete interconnection to a distributed control system or to your PLC and SCADA, and capture the data that you want in a meaningful way that it can go back to a system like SAP or Oracle or ABB or a CMMS or anything, really. So besides the electrical safety considerations we learned about this morning, there are other industrial safety considerations as well. You guys from BP, I'm sure you're dealing with intrinsically safe requirements daily. So if you've got areas of a plant that is at risk for explosion, or just in general at risk for fires, for extreme heat to the operator, etc., these are areas where you've either got to be properly equipped or it just may not be conducive to people going in at all. I'm going to guess from what we were discussing earlier this morning about how hot operating motors can get. Maybe this motor is not operating because the guy's got his gloved hand right on it. But you notice at the shaft connection here, there's no guard in place. So if this equipment is operating and this guy isn't aware, because you can see it's sort of beside and behind him right now, if he moves his arms a few inches back, he could cause himself a very serious injury. My first job after college, I was doing inspection for a corrosion engineering company. So I got trained in a couple of things. One was fall protection, because I was having to do a lot of working at height like this, climbing up to do external and internal inspections on municipal water tanks, exhaust stacks at steel mills and power plants. And I was also trained in doing confined space entry in hazardous environments. So like, did anybody here come over from Gary today? No, I've been inside of a few acid tanks on the pickling line and the Gary Works and at some of the Pittsburgh area U.S. steel plants as well. I don't do that now, but I know what that's like. The more cumbersome PPE you're wearing, the more nervous that you might be in a hazardous environment. Or, in the case of working from a ladder, you're really supposed to maintain 3 points of contact all the time. So that would leave you a free hand to take measurements. So how are you going to take notes? Right? The technology today will capture the data that you need, and then it can wait till you get back down to the ground and unsuited and sitting at a desk in a climate-controlled room, and that's where you can do the important work of the analysis and the data entry and so forth. There are other hazards besides electrical that you'll find inside of a plant. I apologize, the resolution on the projector, even me standing next to it with my bifocals, I can't read it myself. But the takeaway here is that many of the injuries caused by these other industrial hazards, they're due to either poor technician posture, position, so ergonomics. You're putting yourself into a position to become injured. Lack of attention, poor procedures or not following the procedures, poor housekeeping, maybe tripping hazards. You've got electrical cords and receptacles in the floor. Or just losing concentration. Again, if you remember what Rudy talked about, the hierarchy of controls from NFPA 70E this morning, the riskier environments are riskier because they increase the likelihood of human error. You've taken engineered controls, you've taken automation out of it. And in those kind of situations, you've got greater possibility of human error. Whenever you look at the injury rates of these kinds of injuries resulting from these kind of hazards as well, it's a little frightening as well. You see almost a third of these injuries required hospitalization of at least a couple of days. This is not electrical. This is everything else that you'll find in industrial facilities. And then it's about 22%, if I remember. It's about 1 out of 5 will cause a period of incapacity of at least 2 months. So these are non-electrical injuries as well. It is, again, it's important to be aware of all of the hazards around you. We talked a lot about electrical today, but even while you're doing electrical inspections, you may have to deal with these other sorts of hazards as well. Right? So how does thermal imaging fit into mitigating these hazards? Well, there's a few ways. One way, as I mentioned before, if you have an instrument capable of applying a telephoto lens, you can do safe measurements at a pretty good distance. So, for example, I ran through what we call our field of view calculator before, and keeping in mind what I said, that you want to have at least a 3 by 3 pixel square image to do some temperature averaging and get an accurate measurement. What that basically means is if you've got a 7-degree telephoto lens and you're 50 feet away from this target that you want to measure, you can actually resolve a 3/4 inch square target at 50 feet away with a higher resolution camera and a telephoto lens. That's what the technology is capable of. And oftentimes that 50 feet distance, or it doesn't have to be 50, 30, 25, even 10, that distance may be enough to put you or your technicians far enough away from those hazards that it's no longer a concern, right? That's one solution. And I would say, by the way, if you're in an area of the plant where intrinsically safe tools are required, if there's a way to step outside of that boundary and still do a thermographic inspection of some component that's inside of that boundary, this can be a solution then for that as well. All right, another step could be actually intrinsically safe tools. FLIR ourselves, we don't offer many of these. We do make a optical gas imager, and it's a fairly expensive tool, in part because it's designed to be intrinsically safe. and in part because it's really a different technology that we use to identify different types of gases that are invisible to the naked eye. But it happens to be a very good, very sensitive thermal imager as well. If that's really your only solution, if you need to have a handheld tool to take various thermographic measurements and it has to be intrinsically safe, then that's one good solution. Another good solution would be fixed mount cameras that are set inside of intrinsically safe enclosures. We don't make those, but there are a number of automation integration providers, and we partner with many of them. They're all around the world, and they can provide these kind of solutions as well. And again, you'll capture all the data here in a manner that is safe for that environment, but all the data can be transmitted to a better location, to a control room, to a desktop, to a data historian, however you need it to be integrated into your operations. That's a possibility as well. It doesn't just have to be electrical components. We had a lot of discussion today about electric motors as well. Thermal imaging is not going to tell you the actual operating temperature inside of that motor. You and I, none of us can see inside of that motor, so neither can the thermal imager. It will, however, show you accurate measurements of the external temperatures. And I think we heard it this morning, trend is your friend. If you're capturing data from these cameras, whether it's handheld inspections or whether it is continuous monitoring, capture that data, putting it in a database, a historian, an enterprise asset platform, something like that, then you could use that to identify trends over time. Let's say, for example, we've got this row of motors and they're all operating similar systems at similar load. If you suddenly see one motor running hotter than the other two, this can be an early indication that something is wrong. And again, as our motor experts discussed this morning, it doesn't necessarily mean there's something wrong with the motor. It might be something else in the drivetrain. But it does indicate, hopefully early enough that you can plan an outage and not be caught by surprise, that it requires more troubleshooting. It can get fairly sophisticated. I'll show you a slide a little later as well about a solution we did for a data center provider with multiple cameras. But this is becoming more and more common for substation monitoring at industrial and also electric power utility customers as well. They want to serve a dual purpose. They want better security, so they want to be able to detect intruders, and they also want to be able to monitor all of the critical components inside of that substation. Thermal imaging oftentimes can accomplish both. You can use this to identify moving objects that are too big to be natural. You know, and again, an automation integrator, or if you or your colleagues or your electric utility has the talent and the knowledge on staff, they can do that themselves. If not, again, there's this whole community of integrators around the world who are capable of doing that as well. And so the benefit is you can monitor critical components and capture data trends over time for all of the equipment there, and also computerize detection of moving objects that might be a deer, might be a squirrel, might be a person, might be a vandal, might be worse. You know, all of those things could be combined into a single thermal imaging solution. I mentioned the gas imaging, and I'll point it up in this crowd, even though we are ostensibly talking about electrical maintenance today. This is related in one way because there are cameras that will image SF6 gas. That's your insulating medium and high voltage switchgear and some other equipment as well. But this is also representative of that intrinsically safe camera, which is designed to identify methane and a number of other hydrocarbons. And we advertised over 400 various invisible gases can be detected with this technology as well. But again, those cameras happen to be extraordinarily sensitive thermal imaging devices as well. So they're intrinsically safe, they can detect over 400 gases, but for electrical applications, they can be used safely inside of areas where you must have an intrinsically safe tool. Last but not least, when we're talking about safety, even though this may only be tangentially related to electrical maintenance, There are more and more automated solutions incorporating infrared to be used for early fire detection applications. And here again, the idea is if you've got combustible piles at a recycling facility or in a pulp mill, infrared will detect hotspots building before a visual system would detect the flames or the smoke, before the naked eye would even realize that anything is wrong. And these have been used fairly effectively for the last 5-10 years or so to put out little fires before they become catastrophic fires. So, just like we discussed this morning, that discussion about safety leads right into a discussion about reliability. This was a very extreme example that I heard about actually at a different infrared seminar, and but it got me to go do a little more research of my own. This is not hearsay. This is public information. I took this data from Detroit Free Press, I think it was, the one big paper in Detroit, and a screenshot from Bloomberg News as well. There was an explosion, I think it was last year or the year before, at one of Ford's tier 1 suppliers. It wasn't a Ford plant. It was somebody providing components to them. They happened to be the only vendor in the US that were providing these magnesium components that were used in engine mounting of F-150 pickup trucks. F-150, a lot of you probably know, that's the biggest selling pickup in the country. It's one of the most profitable vehicles that Ford makes. And because of this fire at their critical supplier, they were unable to build trucks for 2 weeks. And this seems unfathomable to me, but their average selling price is almost $47,000 per F-150. And in the time that they were down, that was the time that they could have built 35,000 pickup trucks. So if you multiply that out, it's $1.6 billion. I don't think Ford lost $1.6 billion, but collectively, their dealer network had to wait 2 more weeks to bring in that revenue. I think probably the most popular truck in the country, they eventually caught back up and sold those, but there's no putting that money back where you needed it 2 weeks ago. If anyone's working for a publicly traded company, you might hear a lot about cash flow. Heck, even if you're working for a private company, you probably hear a lot about cash flow. Nobody wants to go into the red. Shareholders and analysts definitely don't want to see you go into the red. This was a big deal. They knew it was a big deal. They airlifted a 43-ton die from the US over to the UK to a similar functioning facility so that they could resume production. And then, all those parts that are being built, they can't just ship them across Michigan. They got to bring them back across the ocean through customs into Detroit so they can finish the F-150s. This was a big disruption. So the point I'm bringing this up is, thankfully, nobody was killed in this. But it caused a lot of financial damage. It probably disappointed some customers who thought they were going to get their truck from the dealer 2 weeks earlier than it finally came in. I'm not suggesting that infrared condition monitoring or any of the other technologies that we've talked about today could have solved that problem. But you can all probably imagine other issues where unexpected failure disrupted production and cost somebody a lot of money or time or anxiety or all of that. This is a very extreme example. In that case, I think we're going to have to think about some of the indirect costs. A lot of people at that supplier are going to have to learn new safety procedures. The next time we have a little fire like this, do not allow the fire department to spray water on it, right? Okay, this is one case study that I mentioned earlier. There's a paper mill in Arkansas that made a, I guess, large is a relative term, but they purchased 700 3-inch diameter round infrared windows. They decided that we're going to put these in all of our switchgear, 480 volts and up. So, basically a big chunk of the electrification system inside of their plant now are outfitted with 3-inch round windows. They calculated from that $200,000 purchase, which, that's real money. I don't have $200,000 to spend on windows. But they estimated that they were now saving annually $667,000 because of the increased productivity and the reliability gains that they realized by allowing safer and more effective infrared inspection of that electrical equipment. This is one example. So safety leads to efficiency, it leads to greater reliability. I'm not sure actually of the origins of this, but this is another case study, and it shows a before and after. That infrared is one technology that you can use to identify problems early, and then after the repair or the replacement is made, and it's PDMA left already, huh? Oh, yeah, okay. I mean, I'm not a motor expert. I couldn't say what kind of repair was made, but they did identify that for some reason that motor's running hot. Was it something on the pump side, the machinery that it's driving? Was it a problem with the motor itself? Was it a problem with the power supply? I don't know. But once repairs were made, the thermographer was able to come back, take a similar image, and verify that, okay, now it's running at an external temperature that is more in line with the historical trend. Problem solved. At least by that variable, they're able to verify. One more example of a bearing that was being inspected with vibration analysis as well as thermography. And I'm not making any claims that one technology is superior to any others. The reality is that different technologies are going to give more meaningful results depending on the situation, the application, etc. But in this individual case, vibration analysis was revealing no problems with the bearing. Thermography actually showed it's running hot compared to its historical trend. It led to a rebuild of that bearing under planned outage and minimal disruption, and wound up saving a good bit of time and money for that plant. So again, another example of where thermography is going to be able to give you meaningful information. And if that bearing is down from a motor, maybe that motor was showing that it was running hot also, and that could lead to further troubleshooting to see, well, let's see what else we find here. Maybe a bearing or something else is running hot. And indeed, that's what they identified. I mentioned this case study earlier as well. Data centers are notoriously private about who they are and what they do. While I was with ABB, before I came to FLIR, we were pretty successful at selling the high voltage circuit breakers and the installation services for those to Facebook. But Facebook builds all of their data centers under LLCs with code words that don't make it immediately obvious who the owner actually is. It was pretty neat, actually. So I don't know who this was, but some data center operator, and not some, there's been many, they actually installed a system of multiple cameras. They've got 8 cameras here, constantly viewing their high voltage supply from the utility, because, you know, although they do have good, robust standby power systems internally because they don't want to disrupt service for their customers, they really never want to lose power supply from the utility in the first place. So they installed a more complicated system, 8 cameras, continuous monitoring, to make sure that nothing is going to lead to a failure in that substation. Again, the idea is trend data over time, keep an eye on the critical elements, and as soon as you see something trending in the wrong direction, it gives you time to plan and take corrective action. I'll talk briefly about quality control. And is anyone in the room even directly involved with quality control at your employers? Okay. Very simply put, you've got to do inspections. If you identify defects, that might require either rework or scrap. And your plant operations and finance people, in the end of the day, they want to see an increase in throughput. If Ford can sell 36,000 trucks in a week instead of 35,000 trucks, everybody's happy. Thermal imaging in certain wavelengths, and you know, including the wavelengths that you will find in commercial tools like this, they can see through obstructions that are opaque or obscurant to the naked eye and the visual spectrum. So for example, steam and water vapor in this log conveyor at a pulp and paper facility, you can't see if there's any problems, misaligned logs, etc. on that conveyor. Thermal imaging can show you that. Same with temperature measurement of water and paper going through this vacuum drum washer at a pulp and paper plant. In this case, you can not only visualize a little bit better through the steam and water vapor, but you can actually take multiple points of temperature measurement and even use that in a feedback control loop to the actual control system of that machine as well. This is a more sophisticated application where there are hundreds of temperature measurements being taken continuously, cross-directional width of paper going through a paper machine at one of the pulp and paper mills. And they are absolutely using this as feedback control to maintain quality, to minimize waste, to maximize throughput, to put maximum profitability into their shareholders' pockets, and hopefully also, bonus and incentive payouts to all their employees. The most sophisticated applications I've seen for thermal imaging lately have been in these so-called machine vision applications. This is absolutely an automation integrator opportunity. FLIR does not have the expertise yet to do this kind of thing. But if you can imagine, for example, applying a clear adhesive or sealant on a black substrate, that's very difficult, if not impossible, to measure in the visual spectrum. But thermal imaging comes in very handy for that kind of thing. It will tell you, is the bead wide enough? Are there discontinuities? And if temperature is important, sometimes it is and sometimes it isn't for adhesive bonding and sealing. If temperature is important, then it can tell you if those temperatures are within specification as well. It's gotten pretty clever nowadays. It is thermal imaging which has gone from a pure military application to now these commercial applications, and it's very common these days in electrical maintenance. It's now becoming part of this Internet of Things, of Industry 4.0, of whatever buzzword that you're hearing lately. It's exciting. But really, I want to talk about productivity. And again, I mentioned that I have some cameras in the back, but I want to show you a brief demonstration here of what you can do in FLIR's software. We're not the only ones that make thermal imaging reporting software, but we make a pretty darn good package. I was talking to Mike a little bit at lunch, and you're using Thermal Studio already, right? So the point is, you probably hear this at work. I've heard it everywhere I've worked for the last 10 years. We got to do more with less. We got to maintain reliability and uptime and still work safely. And yet, if somebody on your crew quits, upper management might not necessarily approve that headcount replacement. So now you got 5 people instead of 4 who are responsible for electrical and mechanical maintenance. I've seen it everywhere I've been, and I'll bet a lot of you have as well. There's also this idea of reducing duplication of effort, which is a drain on productivity, and removing that possibility of human error, which is a productivity issue, but it's also a reliability issue as well. Because if you put in the wrong data that suggests you measured no problems with your electrical equipment, but that was just, a fat finger mistake, that could lead to catastrophe, because whatever system you're using to track that data history, its programming doesn't know that there's a problem whenever actually a problem might exist. The last point I'll make about productivity is the Infrared Training Center and other resources as well. There's a number of third parties that provide infrared thermography training. ITC is part of FLIR. We don't make a secret of it, but we do brand them separately. They've got ITC has its own website and its own color scheme for marketing purposes and so forth. But this is the way I got trained, and the way I think a couple of you in the room got trained as well. But again, we're not the only ones. Some of our dealers offer certification training in thermography as well, and our competitors, obviously, some of them do that as well. It's an expense. There's a cost to pay the tuition to attend the class, and you got to leave work for a few days. You got to get your manager's approval. But it's a worthwhile investment for some certified thermographers to be on staff, so that whenever you get to more complicated applications, or if there's some difficulty, uncertainty in interpreting what you're seeing in a thermal image, that's where the certification really pays off, where the expertise really comes in handy. Right? But in the meantime, Vito and I, in another couple of minutes, we're going to show you how these tools they're foolproof enough nowadays that with maybe a few hours of hands-on training with Vito or one of his colleagues, you can have a whole crew of technicians keeping thermal imaging in their tool bag and using it to improve safety, reliability, and so on. Anybody in the room do software integration, IT? No. Everybody here is probably electrical technician, reliability engineer, something like that. The point of this plate of spaghetti diagram is to show that there are many different ways to take the data captured by a thermal imaging instrument and get it where you want it. Now, where you want it might be a report that you print out and put in a file, or it might be one of these numerous systems that exist nowadays for asset management and maintenance management and so forth. So I will show you for the next couple of minutes some things that you can do in FLIR Thermal Studio, which is our reporting software. And a lot of what I show you can be done here. Then you can go and put your hands on one of our cameras and do the same things there as well. I have some images saved that will work from. There is one brand new add-on, so I've added it to the presentation. This just became available this week. We call it Inspection Route Workflow. So it's an add-on for the desktop software, and it's also a firmware update that's available for certain of the FLIR cameras. But it functions very similarly to the tagging system that Rudy was discussing earlier today. You can design an inspection route with the plugin on Thermal Studio, and then upload that to the camera that your technician or yourself are going to take out on that maintenance route. Whenever you come back to the desktop and download the images and the other data that you've captured with that camera, it all goes right back into that inspection route format. In other words, if you say, I want to go to boiler room A, and I want to measure motors 1, 2, 3, 4, 5, you can set up your route in such a way that whenever you come back, all of that data is tagged as boiler room A, motor 1, motor 2, etc. And additionally, you can do additional analysis and measurement on your desktop to capture additional information that maybe you don't have time to do safely while you're out on the floor. So I'll show you that. All right, let me just open up one image here. Okay, this is a shot that you can see from an electrical substation. These are probably disconnect switches, right? Is that what it looks like to everybody? Okay. Civil engineer, not electrical engineer, but I've been in a few substations. So the color palette suggests, well, gosh, this is hot, and the rest of it is not. It may be too hot. It may not be too hot. The other thing you can see from this is, you know, this phase doesn't seem too hot. Those other two phases do. And the next question you would ask in troubleshooting, I think, would be, well, why? Why is there some apparent unbalance between those three phases? Regardless, some things that you can do, let me take all these away so I can start from scratch. What I'm going to show you can be done in the software, but it can be done on most commercially available thermal imaging tools. Certainly the best ones, but many others as well. You can make a spot measurement. Remember what I was saying about a 3x3 pixel square? Spot measurement is going to capture that 3x3 pixel square and then give you the average. So if you're too far away to resolve in a 3x3 pixel, you can't necessarily trust the absolute temperature measurement. You can trust the qualitative results. I can look at this and tell this one is hotter, but you can't necessarily trust the exact temperature measurement. Once again, distance to target so that you can accurately resolve it, that's important. That's the minimum kind of training that all of your technicians would need to have. That said, put the spot on that. Boy, pardon me. Let me see. That's the cold one. I'm not sure if everyone can read it. This spot is reading 126.3 degrees Fahrenheit. Is that, where I put the spot, is that the hottest part of that disconnect switch? Perhaps. That's kind of the right answer. It's a wishy-washy correct answer. So the next type of measurement tool that you can put on this image is a box. So over here we've got a box now. It's telling me the max, the min, and the average of every pixel, of every individual temperature measurement within that rectangle. It's showing me what it is. So as a matter of fact, the maximum temperature is 169, almost 170 degrees Fahrenheit. It looks like I didn't miss by that much, but in the grand scheme of things, I missed by a whole lot. So that's a really nice feature. You can do it here in the software, but you can do it right there on the camera as well. You can change what we call the color palette. Certain color combinations might make problems more apparent than others. A lot of old school experienced thermographers, they really prefer this grayscale. And certainly in this application, that grayscale really shows you exactly what's going on. There's another analysis tool here that is called an isotherm. Isotherm is a visual indication that you have crossed some threshold. And as you can see here, maybe have you gone above, or have you gone below, or are you outside of some temperature interval? So let's see if we can find what this is showing me is every part of that image that is above 120 degrees Fahrenheit. And I made it red because what did we learn this morning? Red is, yeah, red's bad. I mean, you can make it pink or purple or any color that you want, but it really stands out on the grayscale. This is another really effective way to say, okay, we know that if any of these components are operating above 120 degrees Fahrenheit, now it points out where your problem actually is. There's one more measurement tool that I want to show you, which is the delta. And a delta is just what it sounds like. It's some measured difference. So I could say, for example, I want this delta to measure the difference between the max and min in this box. So I will select like so, all right? It's going to tell me the difference between the maximum in box 1 and the minimum in box 1. $173.6, okay. Beginner's mistake. This is actually measuring empty space in the sky behind the image. So you do have to be careful. It's probably better to set an interval or to measure a known spot where you know you're on a cold piece of steel rather than the cold emptiness of space behind you. But
two spots.
Two spots.
Two spots on there, you do your delta between the two spots.
You do 2 spots? You would not do a maximum in a box instead of a hot spot?
Maximum in the box when I'm trying to pinpoint something
Okay.
on an object.
Yeah.
Like you're talking about this B phase of the switch.
Mm-hmm.
But then if I'm trying to do a delta comparison, I'm either going to be looking at a comparable bushing connection point, movable disconnect arm on its sister switch.
Mm-hmm.
And now that's giving me what we're calling a similar delta comparison as opposed to in the box.
Okay. Yeah, that's great. And this is what your overall electrical training can give you. You combine this user-friendly technology with the knowledge that you all already have, and NFPA and NETA gives you guidance on things like this. So what is a meaningful delta, for example? The consensus standards will tell you that. What's a meaningful temperature delta? And that combination of your knowledge and training and the data that you can capture with technology like this, put it to work. One last thing I'll show you, and then we'll fire up the cameras like I've been promising for a while. A project manager, a supervisor, an engineer, somebody may want to see a report in a particular format of all of the measurements that you just took on that inspection route. I won't get into the details of how to do this, but this software allows you to custom create a template. So if you need to have a certain font, certain size, a company logo, and if you want to add notes such as, well, these are the NETA criteria. I'm measuring temperature deltas on these components, and this is the NETA criteria for temperature delta. This is why I'm saying that this motor or this disconnect switch or some other component requires immediate action. You can add all of that to your report template. Whatever data is captured by your camera will be transferred to that report, because all of our data exists as what's called metadata. It's additional text that you can't see, but it's part of that image file. These are ordinary JPEG files, but all of the radiographic and camera information and other measurements that you take, they're all part of that JPEG image file. So that'll all get transferred and then split apart into your report template. But the neat feature that we added that FLIR Tools didn't have for the FLIR tool user in the room is a batch reporting process. So let me go back to this. I've got them all selected. I can right-click that and just say Add to Selected Report. You can select from your templates here. And once you have that selected, check the box, runs through the process. And I've only selected, maybe 8 images or so. So it takes a few seconds, but then in the end, what you've got is a multi-page report of the entire route that you just completed. And of course, you can bring that back to your desktop and do your additional measurements and analyses and other notes that you might want to enter. And in the end, all that data is laid out just the way your upper management wanted to see it, right? Aerial, 14-point, cornflower blue, whatever it needs to look like. It's all there. For what it's worth, these cameras, yes, they're capturing images because it's very easy for all of us to take a look and understand what we're looking at and diagnose where the problems are. But it's capturing data. The radiometric data, they're temperature measurements. All of that data can then be exported from here to, actually I've already got this batch set up. You can also export it to comma separated value tables. They're basically unformatted spreadsheets. And software developers can develop then a process on their side to take the data that you've captured and reported from Thermal Studio and put that into some other historian or database. They can put it in Pi, they can put it in SAP, whatever you're using. Then software developers can take the data and take it that much farther. And again, as I mentioned before, these automation integrators we work with, they also have the capability to send that data and alarm information and recommendations and so forth. It doesn't even have to go through Thermal Studio or any kind of in-between software like this. They can put that directly into the database. They can send alarms directly to a PLC. They can send emails to technicians at 3 o'clock in the morning on Saturday because you need to be notified because you're on that phone tree, and so on. Okay, enough about looking and listening at me. If everybody wants to stretch your legs before you hit the road tonight, Vito's in the back and a number of these cameras are powered on. And if you want to try them out, let's do it. And maybe if you've got questions in the meantime, let me know. Oh, thank you.